Okay, so here we go again with a practice test. I think these are actually coming from assignments that we've already done, but I mean, it's always good practice. I mean, you know, practice, practice, practice. You'll be successful. All right, so what I notice in this problem is they give me a sigma. All right, so that is going to be a standard normal. Okay, this is what the mu is. This is what we're accepting. Here is our sample. Is it now more than? We have a 1%, and so 20 days is going to be our sample size. So we took 20 daily samples. Okay, so that means our average right now is 24,819. The sample average is 25,825, so that's good, making more money. So maybe that old average is wrong. Maybe it's wrong. So we have a population standard deviation, a sample size, and we have a level of significance that is 1%. And the question is it now more than? And in case you are concerned, know that 24,819 turns into 25, so the average is probably greater than 24,819. So the average is getting bigger. It's greater than. Okay, so right now the average is 24,819, and our alternate hypothesis, I think the average is now more than 24,819. All right, so I think that's happening. Level of significance is 1%, which is 0.01, and this is a right tail. So because this has a sigma, this is going to be a standard normal. Which means that we are getting a z. And so the formula that involves the sigma is the x bar minus mu of sigma divided by the root of n. So again, to make this one work, make sure the top and bottom are in their own unique parentheses. This is a z-score, so this will go to 2 decimal places. So the next problem, the p-value is based purely upon what we just found. So a z of 235, again, look that up as a negative. So negative 235. 0094. Okay, it's not a two-tail or anything, so I don't have to do any funny business. This is a right tail, so the rejection zone is technically on the right. This is alpha, which is 5, no, excuse me, it's 1%. I'm sorry. Alpha is 1%. And I see that 0094 is shorter, so it falls into the rejection zone. So I notice that the p-value is less than my alpha. That means I reject H0 and accept H1. So what is it, 24,819? So the null hypothesis was saying that the average is equal to 24,819, and the alternate hypothesis is saying that it's more than 24,819, and these are average daily sales. So we reject that the average daily sales is equal to 24,819, and accept that the average daily sales is greater than 24,819. So again, things that I'm looking for, like the words that you absolutely have to have. So if I'm rejecting H, not accept H, no. So I need to see reject average is equal to 24,819. So I reject that the average is equal to 24,819. And then I need to see accept the average is greater than 24,819. Those are like the key words. And if you can get the context in there, so it makes it more like realistic. But if you just can't, or if you I don't know, just give it a good go. Just give it a good try. All right, next problem. This is an S. This is an S. S right there. Average sample 8 weight times alpha. Is it less than what it used to be is the question. I think that's all that I need to know. All right, so here the average is 18.3. My sample is 15.1, 15.1. We have a sample standard deviation. That means this is a student's T, when we use the T table. N is equal to 8. That means our degree of freedom is going to be 7. And we have an alpha of 1%. All right, so here we go. Null hypothesis. Change colors here. The null hypothesis says that the average is 18.3 minutes. The alternate hypothesis says that it is less than. Okay. And again, if you get confused, you see that 18.3 is going down to 15.1. So my average is less than 18.3. From here, the level of significance is 1%. And the arrow, again, if you don't know, think of that as like an arrow. That arrow is pointing to the left. So this is a left tail. All right, because this has an S, this is going to be a student's T. And because this has the S in the formula, which is x bar minus mu of S divided by the root of n. However, similar to the sigma, we keep completely top and completely bottom in its own unique parentheses. So 15.1 minus 18.3 divided by 6.2 divided by the root of 8. This is a T, so I run out this decimal to 4 places. Z's go to 2, everything else goes to 4. So this is negative 1.4598. So the next step is the p-value, which is built upon, in this case, of a t of negative 1.4598. Just look it up as a positive. And then this, you need a degree of freedom to make the t-table work. That's n minus 1. So if n is 8, my degree of freedom is 7. Okay, so 1.4598. 1.4598. So 1.4598, again, you look that up as a positive with a degree of freedom of 7. So looking at the 7 line, looking for 1.4598, 1.45 falls in between 1.415 and 1.617. Okay, 1.45 falls in between those two, 415 and 617. And And because this is a one tail, okay, I'm not looking at the two tail line, because this is a one tail, that's 0.100 and 0.075. And that is the actual p-value that gets on that line right there. Don't muddy the waters by putting numbers where they don't belong. All right, so those are pretty big. So I'm assuming that they're larger than my alpha. Alpha of 1%. Yeah, those are way bigger. All right, so let's go ahead and figure this out. So this is a left tail, alpha of 1%. I notice that my p-values are both larger than my alpha. So my distance from the edge, this time being the left edge, is larger, and the closer one is 0.75. And 0.75 is 7 times the size of the alpha, so it's way bigger. Yeah. So I notice that my p-value is greater than my alpha. That means do not reject H0. That means we do not have enough evidence to say H1. H1 is mu is less than 18.3. So we do not have enough evidence to say that. So we do not have enough evidence to say H1. Last but not least is the probability problems. So the probabilities, we have 75%, we have 125 out of 189, alpha of 1%, is it less than 75%? Okay, so right now, what is the big probability? The probability claims at 75%. That's 0.75. Q is 1 minus P, so that's going to be 0.25. The sample size is 189, and what we found were rainbow trout were 125. So that makes my sample probability, which is R divided by N, 6614. And we are looking for an alpha of 0.01. Okay, here we go. The null hypothesis says that the probability is equal to 75%. However, we just did a sample and we're showing that it's 66%. So maybe the probability is less than 75%. That's what the question is asking. Okay, we want our alpha to be 0.01, and this arrow is pointing to the left, so again, this is a left tail. Okay, because these are probabilities, we are getting a z-score out of this, which is a standard normal. The z in this situation follows the X bars, and P hats and P's and stuff. Sorry, that's the formula. Again, to make this thing work, we want this numerator and this inside of the denominator in their own unique parentheses. So p hat minus p divided by the square root of q divided by n, what is that? All right, this is a left tail, so this is a one tail. My p-value is based upon this z of negative 281. I always look it up as a negative no matter what, so this is already negative. That's good. So negative 281. So negative 281, 0025. Okay, so this is a left tail, alpha of 1%. And I have a p-value of 0.0025, so the distance from the edge is drastically smaller. Distance from the edge is way smaller. So notice that my p-value is less than my alpha. That means reject H naught except H1. 77%, 75%. So the null hypothesis is that the probability is equal to, and the alternate says that the probability is less than. And what are we looking for? Rainbow trout or something like that? Yeah, rainbow trout. Okay, so we reject H naught, accept H1. Again, the word is probability, not proportion. Probability of a fish being a rainbow trout. Except